So, what is electrolysis? Electrolysis is any chemical reaction that ordinarily wouldn't take place, but does take place because of the addition of electricity. So, the electrolysis that we are going to concern ourselves with is water and electricity, which causes the water to start a chemical reaction moving this way, and it produces or dissociates into hydrogen and oxygen and then heat. So that's the electrolysis equation that we're concerned with. There's many different types of electrolysis. The two main different types are parallel plate and series plate electrolysis. For us, we're going to be worrying about the series plate electrolyzer. So inside this tube here, this tube's about 10 inches in diameter. It's round. It's a PVC Schedule 40 pipe. Inside of there we have equally spaced plates. These plates are stainless steel. You can use other materials, but for our purpose we're going to be using stainless steel. Within the plates there's electrolyte, or the water that we want to create electrolysis with. There's also caustic soda, NaOH. We're using that salt in order to increase the conductivity and reduce the resistance across of this liquid in order to facilitate the flow of amperage across here when we apply a voltage on either end of the electrolyzer. So for our electrolysis, we're going to be using a special type of DC power. We're going to be using a pulsed DC power. So it's not constant, there's pulses of electricity, little lightning bolts going across here. And what's that doing? It's liberating hydrogen and oxygen from the water. And that hydrogen and oxygen is going to travel down a tube. And there's hydrogen and oxygen. There's probably a couple O2s. So we're going to have monoatomic oxygen, we're going to have diatomic oxygen, diatomic hydrogen, possibly monoatomic hydrogen as well. Regular electrolysis uses a constant voltage, or you could use AC voltage, but they use a constant DC voltage. So that's going to produce more just diatomic gas. So this is regular electrolysis, and then this pulsed DC is resulting in a gas called Brown's gas. Now Brown's gas is still electrolytic gas, it's produced from a pulsed DC current applied across here versus a regular constant DC current / voltage across here, which normal electrolysis uses. But we want Brown's gas because Brown's gas is special. It's got more energy in it, and that's not the purpose of this experiment, is to debate whether it's different or not. I've argued enough with professors in school over different types of electrolysis and monoatomic elements. And anyways, the point being is that Brown's gas has profoundly different results when you use it for welding or horticulture compared to regular electrolytic gas. So we're using pulsed DC electricity across a series cell electrolyzer in order to liberate hydrogen and oxygen from water. And then we're taking that hydrogen and oxygen and we're using it for electroponics. So electroponics takes the electrolytic gas that we've produced from our water and injects it into the roots or the root zone, root area of an organic no-till soil bed. And on top of our soil bed we have our trees growing, massive trees. Now why is this beneficial here? Well, oxygen is directly used by the roots of a plant, just as CO2 is directly used by the leaves of the plant, and vice versa. The roots do use a small amount of CO2 from my understanding, and the leaves use a small amount of oxygen for the photosynthetic waste being expelled from the plants. Anyways, directly, hydrogen and oxygen, you can debate about the usefulness of it on the root zone of the plants, but indirectly, when you're feeding it to the microbes and all the little things that are working with the plants here in a symbiotic relationship, it has a profound effect, because hydrogen is used by the microbes. They can use it to asphyxiate atmospheric nitrogen into the soil. That's how legumes work, is when you're planting them for a cover crop. That's the purpose of the cover crop, is to asphyxiate atmospheric nitrogen into the soil. So indirectly, the hydrogen is very beneficial for these guys. So is the oxygen. Or sorry, indirectly, the hydrogen is very beneficial for the plants, because it's directly results in increased microbial activity and the ability for them to asphyxiate atmospheric nitrogen. So the whole purpose of this is we're not focusing on the plants up here. We are, it's just we understand what's really making the plants grow, and it's all the little microbes, all the little worms, nematodes. There's thousands of things in here which I don't know enough about to go into detail, but that's not the point. I know that they all love oxygen and hydrogen, and then all of the bad things, any kind of like molds or algae, they don't like oxygen. That's how nature works. Like, for example, when a stream is flowing in nature and there's vortexes, different swirls and things like that, basically when it swirls, the oxygen molecules within the water are heavier, so it pushes them out into the outer part of the vortex in the creek or the river, and then that becomes a higher concentration of oxygen in the outer part of the vortex. Therefore, that higher concentration of oxygen naturally purifies and cleans the water as the stream flows down. Anyways, that being said, we know that this hydrogen and oxygen is going to decrease bad stuff, it's going to increase the good stuff, and then that will result in increased yields, more importantly, increased nutrients, and increased health of the garden. So unlike most technologies that increase yields of agriculture and horticultural apparatus, setups, gardens, they don't result in increased nutrient density. For example, injecting ammonium nitrate into the fields, corn crops, that might result in increased yields temporarily, but you're depleting the soil of all the microbes and you're killing off the natural ability of the soil to function and sequester carbon and all the good stuff. So our technology increases the nutrient density of the crops cultivated, it increases the yields, it increases the health of the garden, and it creates a symbiotic relationship promoting what's truly important, the microbes and all the little things in the soil. So that when we're done with this soil, after we reuse it for a few years or whenever, you could probably reuse it indefinitely as long as you're adding the correct plants and stuff on top. When we're done with it, we can put it back into nature, and it's better than the soil that we started with. It's higher quality and it has nothing bad in it. So that's what we really want to promote here, is just working with nature naturally in a closed loop, understanding what's truly important, the microbes in the soil, and addressing that by feeding it oxygen and hydrogen, increasing all the good stuff and decreasing all the bad stuff. The amount of electricity and the amount of time that you need to produce this gas is very minimal. You only need to have it on or being produced for like a 2 to 3, 4% duty cycle. So not very much of the time. It doesn't take a lot of electricity, and the yield increase on your crops is profound. 10 to 30% increase in yield and quality. So that's what electrolysis is. That's what electroponics is, using electrolysis, a special type of electrolysis called Brown's gas, which uses pulse DC electricity to liberate diatomic and monoatomic hydrogen and oxygen from water.